Hey, Hallie.
Yeah,
Good morning.
good morning.
Trying to find my hover cam so I can share it. There we go. All right, so you had a question specifically, although kind of jealous with the projects you're finishing up. I'm cleaning and you're putting in new floors.
Yeah.
That was pretty, that's
I
pretty
was
awesome.
confused on number two.
All right, so we've got, I'll zoom in. Choir fundraiser, the number of tickets Allie can buy is inversely proportional to the price of tickets. So the first thing we're going to look at is that it says inversely proportional. So we're going to use the X1, Y1, X2, Y2 formula. And I know Sabrina had asked, and I kind of typed it back to her, where these proportions keep coming from. And I've mentioned it a couple times, and in our notes, we've had it a couple times, where these problems are typically done. And again, I mentioned Khan Academy, where when they teach these, you'll see that the steps, and I even found it at another site. I was Googling a bunch of different ones where it was just direct variation for Algebra 2 high school. And they would have steps. And the idea is that you would solve one of them initially using one of these y equal linear formulas, figure out what the constant of variation is, and then do another problem using a y equals kx formula, similar to how we did it in the beginning of the year, and now use your constant of variation here. The idea is, in both cases, since the constant of variation is identical, if we solve for k in every one of these using the transitive property, we can set them equal to each other. So when we looked at direct variation first, that's where that was. In inverse variation, kind of the one we're talking about right now, I didn't write the initial equation down, but the initial equation was actually y x equals ky and x equals ky. And then when we would solve for k, it would look like this again. So it would end up that using, after we get them this way, our means extremes formula would end up looking like this. So in each case, we're having actually two problems set up as one proportion so that we can kind of save some steps. So I just wanted to toss that in there because Sabrina had asked that. So this part, Choir Fundraiser, really has nothing to do with it. It's talking about the number of tickets. So before is our Y, is inversely proportional to the price. So that's our X. Information that gives us a basis is always before the question. So anytime we look at where the question is find, or how many, or how much, this is where the Y2s, X2s show up. So here it says she can afford 15 tickets. Well, the number of tickets is our Y1 at a cost of $5 each. That's our X1. How many tickets can she buy if it's $3? So number of tickets is Y2. How much can she buy? X2. And then just plug that in. And label, of course. So when you have X1, you have 5. Y1 is 15. X2 is 3. And Y2 is our unknown ticket. Oh, I did it wrong. Nobody told me that. This should be a 2 and this should be a 1. I knew I didn't flip-flop something. I looked over at my formula sheet. This should be T. And this should be 15. Sorry about that. Yep, had I written the formula right, we would have been okay. So I'll let you solve from there, just make sure when you do look at this, that was the first thing I did. I labeled X and Y and then made sure I did, of course, the correct formula. Any other questions?
I would like to look at number 4, if that was okay.
Yep, number 4. Well, let's make sure this time I write the same formula or the right formula. So cheers at a sporting event varied jointly. So here's varied jointly. Hey, bud, get down. So varied jointly is going to be y1 over x1 z1, y2 over x2 z2. And so cheers at an event, so there's our y, varied jointly with the number of fans, x, and the square of the jubilation factor. Yeah, I stole this off the internet. So it says when we have 100 fans, here's our x1, and the jubilation factor was 4, there's our z1. There were 1,000 cheers. So cheers at a sporting event, there's our y1. How many cheers, there's our y2, were there when there were only 10 fans? So again, x2, whose jubilation factor was 20, and there's our z2, and I have clearly no idea why I didn't edit that better. So plugging that in, y1 is 1,000, x1 has 100 fans, and z1 was the square of the jubilation factor, so we're going to have to take 4 and square it. And then our y2, we don't know, so that's how many cheers. If there were only 10 fans and a jubilation factor was 20.
You'd square that one too, right?
You absolutely would.
Awesome.
And kind of like we did the other day, I would simplify all of that first before cross multiplying. That way you don't do too much in your calculator.
Awesome. Thank you.
Anything else, guys? Now, again, as you're thinking, I want to go back just because, again, it was the question. And here is an instance where this joint variation, because that was the question you just asked, when we talked about those 2 steps that you'll see Khan Academy will put out there if you go and listen to his video on how this is done, or if you, and I don't even think I have any of the sites still pulled up on my stuff, so I can't share that screen with you, but you'll see that they will, for one situation, figure out what the constant of variation is. So for instance, in this example, where we have X, Y, and Z, our initial problem, if we would have solved it using the 2 steps, we would have taken y equals kxz, we would have plugged in for y 1000. We would have plugged in for x 100, and for z that 4 squared. We would have worked that out, and we would have taken that 1000 equals 1600K. We would have divided and then simplified that. We would have then set the problem up again for the second scenario, this time plugging in our simplified K factor. And then in this case, it would say how many cheers. And we would have ended up with our 10 and our 20 squared. And I would venture to guess if we worked out both, you're going to find they're the exact same thing. So the idea that we're using these proportions, and again, it was a question Sabrina had asked, it saves from having to do one step going back and starting the problem again. It's by solving for K in each of these, because that's the thing that's the same, you're able to set it up as a proportion and just cross multiply. So it kind of saves some time.
Somehow I got different answers. Hold on.
Say it again.
Somehow I got different answers. I don't know how I did that.
Both cases?
Yeah, in the second case. The difference in like zeros though.
So I would be careful, because if you look here, you can see the constant of variation. Do you see how it would be 1000 over 1600?
Yeah.
So it should still work out.
Okay.
So that's why I said the proportions I've always felt were a lot faster. Any other questions?
That's it for me.
Okay. Anybody else? I see who my participants, Kayla and Hallie. I know we answered your question, Laura. Everybody good?
Yep, I'm good.
All right. Just remember, this is ideally, this is due by Monday, but Monday again by midnight. And I know you guys handed stuff in. Some of you emailed it to me, which was great. Some of you sent it to Google Classroom. That works too, now that I know to look there. I'm learning a lot, needless to say. But doesn't really matter. You guys can turn it in either way, and I will have that graded and sent back to you. Just make sure, if for some reason you guys printed this, like you had the capability of printing the worksheet yourselves, I will tell you that the work and the answers get crammed really tight onto this. So just make sure that you either circle your answers or make sure they're very clear. Or if you did them on a separate sheet of paper, I'm certain I'll be able to find them pretty quickly. So that's it. That's all I have. I hope you guys have a great weekend. Hope it doesn't snow anymore. I'm getting a little tired of that. So
Yeah, that's a little weird. Thanks,
yeah.
2020, you know.
My dog was the only one yesterday who seemed to enjoy it. So, but I really thank you guys for participating daily. I appreciate that. So we'll go again Monday.
Bye-bye.
All right, guys. See you later.
Bye.
Bye.